What are carbon capture utilization technologies? Imagine turning a pollutant into a product that benefits society. That's what carbon capture utilization technologies aim to do with carbon dioxide, a major greenhouse gas. These methods are part of green technology efforts to fight climate change and promote sustainability. They focus on capturing carbon dioxide emissions from factories, power plants, or even directly from the air. Once captured, this carbon dioxide is used to make useful items instead of being released into the atmosphere. This process helps reduce the amount of greenhouse gases contributing to global warming. The first step in these technologies is capturing the carbon dioxide. This can happen in several ways. Chemical absorption uses special liquids called amine solutions to trap CO2 from gases. Membrane separation involves filtering gases through thin, selective membranes that let CO2 pass while blocking other gases. Solid sorbents are materials that bind with CO2 and releases it when heated. There are also direct air capture systems that pull CO2 straight from the atmosphere, which is useful for reducing existing carbon levels. These capture methods vary in size and cost, with large industrial plants typically investing millions of dollars to install them. For example, capturing 1 ton of CO2 can cost between $20 to $50, depending on the technology used. Once the CO2 is captured, the next step is utilization. Instead of storing it underground, the captured carbon dioxide is turned into products. It can be combined with hydrogen to produce synthetic fuels like gasoline or jet fuel. This is especially helpful for sectors like aviation and shipping, where reducing emissions is tough. CO2 can also be used to make chemicals that replace those derived from oil and gas, helping industries lower their reliance on fossil fuels. Another common use is in construction materials. For example, carbon dioxide can be chemically bonded into concrete, making it stronger and more environmentally friendly. Additionally, CO2 is used in food and beverage industries for carbonating drinks, in cooling systems, water treatment, and even in enhanced oil recovery, where it helps extract more oil from underground reservoirs. Transporting the captured CO2 is an important part of the process. If it's not used on site, it is compressed into a liquid or supercritical state and moved through pipelines, trucks, or ships to facilities that can utilize or store it. Pipelines are the most common method for large-scale transportation, often stretching hundreds of miles. These technologies are especially valuable in industries where cutting emissions directly is difficult, like steelmaking, cement production, and heavy manufacturing. They help create a circular economy where waste carbon becomes a resource. When combined with other green practices like renewable energy and energy efficiency, carbon capture utilization can significantly cut overall emissions. However, CCU is not a complete solution by itself. It works best when integrated with carbon capture and storage systems that permanently store CO2 underground. This combined approach is called carbon capture, utilization, and storage. It aims to manage emissions comprehensively and help reach global climate goals. In summary, carbon capture utilization technologies capture CO2 emissions and turn them into useful products. They support sustainable industrial practices and help fight climate change by transforming a harmful greenhouse gas into valuable resources. This approach offers hope for a cleaner, greener future where industry and environment can thrive together.